I'm going to go through both FRQ1 and FRQ2 with you, and that shouldn't take the whole period as long as you guys are with me, okay? And you are grading yourself on this. All four of your FRQs are worth 6 points, okay? And there's 6 parts, so every question, every piece is 1 point, and there's no partial credit. You either get the point or you don't, okay? So it's pretty straightforward. You guys are going to have to kind of make a decision on whether you think you earned that point. And if I were you, I would go lower than higher, just to really see what is the worst case scenario. Because remember, once we are done going over all 4 of these, I think tomorrow, we should be able to look and see what our mock exam score was. And we had not reviewed yet. We hadn't even finished polar stuff. I think there was 2 or 3 sections left that we still hadn't done, okay, if I remember correctly. So scoring yourself lower than higher is really going to give you a better read, because you already know that you would do so much better on that multiple choice now. And we're going to do another one, okay? We will do another in class, during class time, practicing all those multiple choices and stuff, and the FRQs. So the FRQs I think we're most concerned about. It's the feedback I've gotten. There's 4 of them, of course. We've done 4 of them, and I have tons and tons of practice ones that we're going to be using to practice these. But the good news is, once you go over FRQ 1 and 2 with me and everything, but let's just talk about 1, and then you do another one, and then you do another one, you kind of just know what to expect, because there's certain things to each one of these FRQs that are always going to be there. And I'm going to give you a 1-page, just because I like to give you lots of paper. I'm going to be giving you this, which tells you exactly what to expect for each FRQ. And we're going to go over these 2 in class today anyway, so you're going to see that. But you're going to see that there's always this, so there's always this. And so we'll talk about that more. But let's go ahead and start this FRQ. This is calculator active, okay? And when I give my solutions, when I write down mine are what are called model examples. When I give you my answer, that is what College Board said is the best answer you could give, okay? And that's obviously full credit. That does not mean that something a little less than that wouldn't get that point, okay? And I'll kind of try and talk about that as we go through, all right? So here we have we have 2 functions, one given to us as a table and one given to us as an equation. And it says F, so this one's F and this one's G. Okay, so we have 2 different ones. One is F and one is G. The first, A1, is saying to find a third one, which is H of X. This is using composition of functions, where you take one function and you plug it into another one. These mean the same exact thing. They're both, you can use either one interchangeably. But what we're trying to find is H of 5 as a decimal, and we're going to plug F of 5 into G, and that's what we're going to start with, okay? So let's start with how we would set this up. So for part A1, we would say H of 5 is G, and I'm going to use the one with the parentheses. Okay. Are you talking to me? No. Okay. So H of X, and you could have used the G, the little open circle symbol, or this, okay? One thing that was talked about, and I watch a lot of videos from College Board about how kids should answer these things. One thing I think they're going to be kind of picky about is correct notation. So notice how this is written. It's F of 5, that you know exactly how to write, and then put parentheses around it, because it kind of looks weird with all the parentheses, but we want to make sure we know how to write that. Okay, so remember, what's in the parentheses is your input. So this is your X value, right? So when I go to F of X, which is this one, because I'm starting there, F of X is 30, right? When I plug in 5, I get 30, X, Y. So I get G of 30. Now I'm going to take the 30 and I'm going to plug it into my G function. So I'm going to take 30 and plug it in everywhere I see an X, okay? And this is a calculator active problem, like we know, so you don't have to show the work for here. You don't have to show another step where you've got 30 to the 3rd power and all that stuff. You can go right to your answer here. And when you plug this in your calculator and you get your answer, there's two ways you could write it, okay? Rounding to 3 decimal places is always what you're going to do. But there is another option, and this option is good for those of you that are not good at rounding. It's called truncating a decimal. And that means whatever the third number is, you don't have to worry about what you do to it. You can just chop it off right there. So in our calculator, when you do this, the number after the 2 must have been a 5, 6, 7, 8, or 9, so you would round up. But this truncating is just going out to the third number and chopping off whatever came after it. Either one of those is perfectly fine. Okay, full credit for either of those answers. Okay, so you don't have to show the computations. You're just showing the process of how you got to it. But we know as graders that this is a calculator problem, so we know you put that in your calculator to get that answer. Okay. So find the value of f to the power of -1 of 4. What does that mean? What does that symbol mean? Inverse, right? Switch x and y. So normally, like if this was just f of 4 without the -1, 4 would be your x value. So you'd go to the table and you'd say, oh, answer is 15. But inverse means this is your y value. So I go to where y is 4 and I grab the x value. And that's all you have to write, okay? What you wouldn't write is just 3. If you just wrote 3, I don't know that you would get credit. They want to see proper notation, okay? Yep. Yes, you could write it in words. That would be okay. Yeah. The inverse of 4, I guess. Yeah. Okay. So part B, we have 2 more questions. Find all the values of x as decimal approximations for which g of x equals 4. Guys, g of x equals 4. Remember, g of x is like y. We want to know what is x when y is 4. Okay? And this is a calculator problem. So we don't have to actually do this work. Let me show you. So we're going to use our calculator. So g of x equals 4. We're going to use these little arrows a lot in our FRQs. They're just kind of showing, okay, we're starting with that, then I'm going to this next thing. So this is what I'm given, x to the third plus 11x plus 23 over x minus 2 equals 4. That's what we're trying to find. Now, you could probably do this algebraically, multiply both sides by x minus 2, all that stuff, but you don't need to do that. We're going to go right into our calculator. So we're going to type the equation into our calculator. You are going to put your numerator and your denominator in parentheses. And what we want to do is find the x value when these two are equal to each other, right? Intersection, that's what this is. What's the intersection? So I'm going to make a horizontal line at 4. Now, what's nice is FRQ1 will always be an algebraic equation. It's not going to ever be like sine or cosine or any of those. FRQ1 will always be from unit 1 or 2, which was algebra-based stuff, not trig. So remember, you're putting your numerator and your denominator in parentheses, second equation equals 4, and then you're going to graph it. And you can play with your window, but you don't need to. You can see quite clearly where the two intersect. So whatever that x value is our answer, where they intersect. So I don't need to mess with my window or anything. I'm just going to go to second, calc, and then intersect, and find your cursor. Okay, so I just want to be somewhere near it. And remember with intersect, you hit enter and it jumps to the other equation. That's fine. Just hit enter again and then guess. And you can see when y is 4, x is this number right here. It says it on the bottom. There's your ordered pair. When y is 4, x is that number. So the answer is Part 2 asks for the end behavior of g as x decreases without bound. Decreases without bound. The bound word means infinity. Goes on forever. No boundary to cut it off, okay? Express your answer using the mathematical notation of a limit. So this is saying you have to know how to write limit notations, okay? So let's look at that again. We want the limit of g of x. We want to make sure we know which function we're talking about because it goes in our limit notation. So it's the limit of g of x as x approaches, and it says decreases, goes down. That's negative. Is what? What are my y values doing as my x values go to the left? So let me you don't have to take this out, but last period I think they needed me to. We're just looking at this graph. As the x points, as we go over here, where are the y values going? Are they going up or are they going down? Up. They're going up. Okay? I mean, you can zoom out if you need to, but you can see it. It's going like this. So as we go to the left, the points are going further up. Okay? So we would write infinity here. And that's it. You don't have to write any words or anything. That's answering the question completely. Okay? All right. Use a table of values to determine if f is best modeled by a linear, quadratic, exponential, or log function. While we have certainly done this before, I told you that this would be coming up in an FRQ, and because we had two questions right in a row, like around 25 and 26 or somewhere around there, where we had to look at a table of values and decide if it was one of those four things. So whenever we have to do that, we first look and see where the action is. In this one, it's the y's. So for three of them, stuff happens to the y's, okay? So if something's going on with the x's, meaning that the change is really happening in the x's, we know it's a log function, okay? Exponential, linear, and quadratic changes happen on the y's. So what we're going to do is say, okay, we know it's not log. It's going to be one of the other three, but let's decide which one it is. And this is when we say, all right, am I multiplying by something as I go left to right? Am I adding or subtracting as I go left to right? So here's the thing. You have to decide what's faster for you. Is it faster for you to come up with the first and then second differences is what's going to happen here? Or do you want to plug these points into your stat, enter, and then try the different regressions, okay? You could type in linear. Do the points look linear? Or maybe just plug these points in and graph it and make a decision. I don't know. I feel like that could take up a lot of time. These questions are only 15 minutes. That's not a lot of time, so you don't want to waste too much time. And I think it's faster just to do -3 minus -6 and 4 minus -3 and so on. So I can go through this table. Remember, going backwards, I'm subtracting. -3 minus -6 and so on. I'm going to get, I don't know what I'm going to get. I don't know what it might be. -3 minus -6 would be 3. This would be 7. This would be 11. This would be 15. They're all positive because I'm going up. These are my first differences. They are all different. Then this means it's not linear. Okay? Then I want to take those numbers and this is not work you have to show. Okay? It didn't ask us what that number is or anything like that. You'll see. So what's happening here, I'm adding 4 each time. These are my second differences. That means this is quadratic, okay? So let's put that in a complete sentence. Oh, where's my paper? A quadratic function best models the data for f of x. Okay? Just said what model, which one. Part 2 is always going to be a reasoning. Why? Why are you saying that? Was it a guess? You can't just get away with guessing, okay? You have to know what, and you have to be able to put it in words. And this is that part of the this is the part of the FRQ I told you we're going to practice it. I wrote important. We're going to have to know that language. They love this type of stuff. This is definitely going to be something we're looking for when we grade these. The rate of change over this. Remember, this is the model answer. I'm going to write out the best possible answer, and then I'm going to kind of take it down a notch for you on this one. I'm going to stop right here. The rate of change over consecutive equal length input values are linear. Remember, the x values are just going up by 1. They had a common difference of 1. The inputs, okay? So, did you have to say all of that? Probably not. You maybe didn't have to say linear, but they do want you to say something about how the input values are constant. The change in them are constant. So, you could say linear. And the rate of change over the rate of change. So double rate of change is basically what we're saying here, is of output values is constant or are constant. I want to say they said something about not just saying second differences. They want to hear, I mean, if you added that in here, it wouldn't take points off, but they want you to say the rate of change over rate of change. Like, say it in that way, like a double rate of change, not just second differences. That's what we call it kind of in layman's terms, but what is it? It's the rate of change over the rate of change is constant. So don't just say second differences are constant. I don't think that would get you the point. The point of that first part of the sentence, guys, is that if you let's just say our x values we're counting by like, it went like 1, 2, 7, negative 8, 6, it would be neat, and none of those types. The input values have to change in the same way, meaning going up by 1 or going up by 2, or it has to be constant, okay? So if that weren't happening, it wouldn't matter what the y's were doing. So that's why that first sentence is kind of important. Like I said, you don't have to say linear. In fact, I'd say that's probably not, well, I guess it's fine to say that. It doesn't matter, really. Your first differences of the inputs are linear because they're the same, but you could just say that they are the same or constant. That's important. Okay. So there's FRQ1. Let's go to FRQ2. All right, another calculator active one. FRQ2 will always come from Unit 1 and 2 as well. So just remember, Unit 3 is when we introduce trig, okay? So when we say something's in Unit 1 or 2, you're not going to have any trig, including any of the graphs that have to do with trig, okay? And remember, there's no polar anywhere in the FRQs, okay? But FRQ2 will be a real-world problem, okay, whereas FRQ1 will not be, all right? So what happens in FRQ2 is that we're going to do some math, but we're going to have to say in words what that actually means. So I modeled very poorly for you, I feel like, because I sometimes I read these word problems and my eyes glaze over, and I'm like, let me just get to the math of it, okay? But in FRQ2, you definitely have to understand what the words are saying. What do they mean, okay? So let me read. The table above shows the population of a bacteria present in the blood sample of a patient prior to prescribing any medication for infection. So we have the time in hours and how much bacteria is in their blood, okay? The number of bacteria present in the sample was observed over a 6-hour period and is recorded in the table. So they're telling us that you could model this with an exponential function. That's very helpful and very important, where B of T is the bacteria in the blood sample and T is hours since the initial sample reading, okay? So part A is to use the data points. They give us 2 ordered pairs out of there to write 2 equations that can be used to find the values for constants A and B in this expression. And then part 2 is to find those values. So I'm going to take those 2 ordered pairs, which are 1 and 76 and 2, 98, came right out of here, and we're going to plug them in to this. Now remember, fancy letters because it's a word problem, but this is just that, right? T is your X value, B of T is your Y value, all right? Or you could say my 1 and 2 is T, and 76 and 98 is B of T. Just understand what you're working with, okay? And so I'm going to go ahead and plug right in. So Y equals A times B to the F. There's one equation. And then another one would be Y equals A times B to the X. So that's it for part A1. Just being able to successfully plug those in. Okay? Now we're going to solve. Part 2 is the actual find A and B. So think about, so this is using your algebra skills. And like I said, we're going to practice other FRQ2s. Like this one is exponential. We could have logs here. We could have piecewise. We could have a polynomial, like a quadratic. So I'm picking FRQs that are like kind of trying to cover different options. But they're always going to be like make an equation, solve for the variables. It just will be different equations. All right, so let's do this. Let's just take that first one and let's solve for A. Now there's definitely more than one way you can do this. This is just how I saw it. You could start with the second one. You could solve for B first. I'm just solving for A. So A would equal 76 over B, right? Just divided both sides by B. Okay. Then I'm going to take that B, and I'm going to take the other equation, and I'm going to plug that in. So I'm going to take that A equals 76 over B, and I'm going to plug it into this equation. That will get rid of the variable called A, and I can solve for B. So I'm going to go 76 equals, I'm going to plug in A, times B, whoops, should that be a 98? Sorry, make that a 98, fix that. 98 equals A times B to the second. So I'm just plugging it right into this one. And I'm going to solve. So I'm going to be able to get my B value right away. So that would be 98 equals 76B. I'm just subtracting my exponents, right? That's B to the first on the bottom. You can multiply straight across and then simplify, or you can simplify right here. 2 on top, 1 on the bottom, we have 1 left on top. And then B would equal 98 over 76. And let's go ahead and get a decimal equivalent. 98 divided by 76 would be 1.289. Oh yeah? Hakeem, come on. All right, we have B. Now we need A. I'm going to use my B value, and you can really plug it into either one. It doesn't matter. The first one looks easier because it's B to the first power, so I'm just going to choose that. So 76 equals A times B, and that's to the power of 1. I don't really need it. Actually, what should I have put there instead of 1.289? 98 over 76, right, Janet? Because this is rounded. We don't ever, I did it on purpose, so you guys could learn from that. You never, ever want to use a rounded answer anywhere in an answer. You're always, always, always going to use the exact answer and round as the last step, okay? So I grabbed that erroneously. I should have used 98 over 76. Okay, still the first power. So I'm going to put this in my calculator. So I'm going to get 76 divided by that. Okay, I'll even write it. Okay, so I'm going to be putting that in my calculator. And let me show you that truncating thing again. 76 divided by. Don't forget, if you're dividing by a fraction, you need to put your denominator in parentheses. It's really important. Okay? And I get 58.939 if I round, or 58.938 if I truncate. Either one is perfectly fine. Okay? Yep. Yep. Okay. Good. So using your algebra skills, and it's nice because they gave us a 1 with a 1. They're always going to do that. That makes that first one really easy to solve. Okay. Next part. Use the given data to find the average rate of change from 1 to 4. Okay. Express your answer as a approximation. And it says to show the computations that lead to the answer. Okay. So we've done rate of change a million times. We're taking 2 ordered pairs here. They said T is 1. So I'm getting the ordered pair right out of the chart. And T is 4. And that's 154. Okay, and so what we're going to be doing is B of 4 minus B of 1. That is a fancy talk for the y values of x, the y value of 1. And that would be 154 minus 76 over 3. This is showing computations, okay? We're showing each step. Okay, 154 minus 76 is 78. And then in my calculator, 78 divided by 3 is 26. Now, let's remember, this is a high-stakes test. 26 what? What are we even talking about? This is bacteria per hour, okay? B of T is bacteria, T is hours, so it's changing approximately by 26, positive. It's going up from hour 1 to hour 4. That's the average rate of change per hour, okay? Part 2, here's where we have to really start using our words. Interpret the meaning of your answer from 1 in the context of the problem, okay? So again, I'm writing the model answer here for you. For every hour from 1 to 4, could you have written that like T equals 1 to T equals 4? Yes, you could have written it like that. That the infection is not treated. Bacteria in the blood increases, because it's positive, right, at a rate of 26 bacteria per hour. So just giving in words what we just found. What did that part 1 tell us, guys? Okay. Part 3, guys, stop talking, please. Part 3, consider the average change. Okay, so listen, this one I had to read a couple times. Like, I had to read it a few times to understand what it was asking. So listen. Consider the I'll put the whole answer for you in a minute. Consider the average rates of change of B from T equals 6 to T equals H, where H is greater than 6. So anything after 6, 7, 27, whatever. Are these average rates of change less than or greater than the average rates of change from 1 to 4 hours found in part 1? So what they're saying is, we just found that the average rate of change from 1 to 4 was 26. If we go from 6 to anything later, are those going to be greater than or less than the A rock we found up here? Well, think about what you know about exponential functions. Remember, this is an exponential function. They told us that right here. And if you look, the numbers are getting bigger. So as time goes on, the y values are increasing, right? It would make a graph like something like that, okay? I mean, if you had time, you could absolutely type this in your calculator and kind of look at it, but you should be able to kind of know that. And so as the time goes on, these numbers are getting bigger. And so, but for the basic concept that this is an increasing, the numbers are increasing, so are the A rocks going to increase, okay? So I'm going to put up this paragraph for you. Some of you will want to write it. So this is the model answer. The average rates of change for B from t equals 6 to t equals h hours is greater than the average rate of change from t equals 1 to t equals 4 hours because B has exponential growth. The graph is concave up. Therefore, the average rate of change is increasing over equal length input values as t increases. I mean, that's a lot of words. But again, that's the model answer. That is like, you got it, for sure. Could you shorten it in some places? Yes. Of course you could. But the more we practice like the model examples, the easier it's going to be for you guys to spit it out on exam day, which is 3 weeks from today, by the way. Time is flying by. Now listen, we're almost done. I know some of you are writing this. I promise I'm going to put this one and the last little paragraph up in a second when I pass out the homework. I'll put this back up for you guys. Okay, guys, listening. Let me just go back to the question. I'll put it back up in a minute. Last question. For which t value, t equals 4 or t equals 12, so 4 or 12, should medical staff have more confidence in when using this model? Give a reason for your answer based on the context of the problem. So, like, if you put this in your calculator and did an exponential regression, so you use stat, enter, put in list 1, list 2, stat, calc, exponential regression, you store it, you graph it, you look at the table values, you can make some predictions, right? You could predict what's going to happen at 12 hours. You could predict what's going to happen at 24 hours if this patient is left untreated, okay? You don't give them any medicine. That's what this is about, okay? Should you have more confidence, though, as a doctor, in your model, should you have more confidence with t equals 4 or t equals 12? It's almost so obvious that it's staring you in the face. This is, remember how many times we've talked about this? This is actual data. This is real data. At 4 hours, we have 100% confidence that 154 bacteria, because we know it. We tested the blood or whatever. So 4 is 154. That is true. But at 12, it's an estimate, right? After 6, we don't really know what happens. It's a model. It's a way to predict, but it's not necessarily exact. So you would definitely say that the medical staff can be confident using the model for t equals 4 hours. The regression model is appropriate for 1 to 6, and for t equals 12 hours, there's not enough information, okay? So model answer again, but in your own words, somehow saying 4 is the real data, 12 is not, okay? It's a prediction, it's a model, it's a guesstimate. Now listen, I told you guys I'm having that mouth surgery on Wednesday, so I won't be here. You have Miss Thrasher as sub for me before. What? No, I'm getting an implant. They're drilling into the bone in the bottom of my jaw. Yeah, it's good times. Anyway, we're not talking about it yet. I'm trying not to think about it. Everything's okay. Everything's fine. I'm going to give you 2 FRQs. One to practice number 1, one to practice number 2 today. Tomorrow you'll get 1 more. And then Wednesday you can work on, you can work on those in class, but there's also your progress monitoring Your last one in College Board is now open. You have a week to get it done. Remember, it's just 10 homework points no matter how you do on it, okay? It's all about the polar stuff, so it might be a little bit harder. See how you do. But you have a week to do that progress monitoring. So between now and next Monday, get that done. And you have Wednesday with me not here. You can work on any of these things that you want. So bring your laptops, work on your FRQs together. One more thing, I'm almost done talking. Listen. I'm going to give you 2 sheets of paper. The pink one has R4 and R5 on it. It says at the top corner. These are 2 FRQ1 practices. I'm just assigning R4, okay? So don't worry about R5. We'll probably do it another day, but you're not assigning. Just trying to use both sides of paper, and I want to keep FRQ1 and 1 together. And then R7 has R7 and R8 has 2 FRQ2. Just doing R7. So you're not doing all 4 of these. You're just doing R4 and R7. And we might do the other 2 as part of our so R4 and R7 find that side. So we'll start with R1. Think about how you're going to grade those FRQs. R4 and R7. Not all. He's in Romania now. Yes? Did you check the No, I didn't check my phone while I was teaching, and now I just saw